हेलो डियर व्यूअर्स, वेलकम टू विजन फार्मेसी। हमारे आज के वीडियो में हम बात करेंगे कंपैरिजन बिटवीन क्रिस्टलाइन एंड एमोर्फस सॉलिड। तो शुरू करते हैं हमारा आज का वीडियो। उससे पहले आप सभी से रिक्वेस्ट है, प्लीज़ डू लाइक शेयर सब्सक्राइब माय यूट्यूब चैनल और बेल आइकॉन ज़रूर प्रेस कीजिएगा फॉर गेटिंग अपडेट्स ऑन अपकमिंग वीडियोज़। लेट्स स्टार्ट। तो सबसे पहले हम बात करेंगे बेस्ड ऑन स्ट्रक्चर। ओके, तो crystalline solids have a ordered and regular arrangement of molecule, whereas in contrast the amorphous solid lack this order, resulting in disordered and irregular arrangement of molecules. Then when we talk about second point, that is definite melting point, crystalline solids exhibit a sharp melting point, means they melt at a specific temperature, whereas amorphous solids on other hand, they do not have definite melting point and they tend to soften over a range of temperature. ठीक है, मतलब जब जो क्रिस्टलाइन सॉलिड्स होते हैं, जब हम उन्हें हीट करते हैं तो हमें एक शार्प मेल्टिंग पॉइंट मिलता है, वेरस जब हम एमोर्फस को मेल्ट करते हैं या फिर हीट करते हैं तो फिर हमें रेंज मिलता है, एक पर्टिकुलर शार्प मेल्टिंग पॉइंट नहीं मिलता। अगली बात कर लेते हैं हम सॉल्युबिलिटी के बारे में। तो व्हेन वी टॉक ऑफ सॉल्युबिलिटी, इट इज़ generally less soluble than amorphous form and solubility can be predictable. हम अंदाज़ा लगा सकते हैं कि soluble कब होगा, whereas in case of amorphous they are often more soluble due to higher energy state and faster dissolution rate. Okay, then talking about stability. Now let me tell you that the crystalline solids are generally more stable under various conditions and are less prone to degradation, whereas amorphous solid in contrast are less stable and are more susceptible to environmental factors such as moisture and temperature changes, which can affect their performance. In terms of their mechanical properties, we can say that crystalline solids are usually harder and more brittle, while amorphous solids are generally softer and more flexible. Okay, this difference can influence how this material behave in formulation and during their handling. Now let's move further. So when we talk further about their density, then we notice that crystalline solids have a higher density because of their packed structure, whereas amorphous solids have lower densities resulting from less packing. Then the next point is the phase transition characteristics also differ, right? So we'll talk about phase transition. So crystalline solids have sharp phase transition at their melting point, while amorphous solid experience a gradual transition without a clear melting point. Then when we talk about the properties, so this property also affect the storage requirement. Crystalline solid may need specific condition to maintain their stability, while amorphous solids are more sensitive to temperature and humidity, therefore require a controlled environment to prevent its degradation. Then talking about next point, that is drug release. Okay, so drug release profile, when we see, then crystalline solids typically provide a slower and more controlled release of active ingredient, making them suitable for long-term storage, whereas amorphous solids often result in fast release, which can lead to burst release profile. Getting? Then when we talk, that is its implications for drug formulation, then we can say that crystalline and amorphous solid exhibit distinct properties that significantly impact their stability and performance in drug formulation, right? Crystalline solids are preferred for their stability and control release, while amorphous solids are having advantage for enhancing solubility as well as bioavailability, right? So this is in general comparison between crystalline solid and amorphous solid. So thank you for watching this video till end. I hope you have understood the difference between both. Thank you.